Okay, so here I have my setup for fermentation. In my fermentation setup, I have one flask with a cork in the top and a tubing going across to another flask which contains lime water. In the fermentation flask, I have yeast, glucose powder and warm water, about 37 degrees, and that's the fermentation chamber where it's happening. When the fermentation goes on, the sugar is turned into ethanol and carbon dioxide. So the carbon dioxide gas will then leave the solution, and this tubing is meant to collect it and put it into my lime water. So I weighed both to begin with, and as expected, this flask lost mass. We know in chemical reactions, matter can't actually be created or destroyed. It means it's gone somewhere. And the purpose of this setup was to capture the gas CO2. In lime water, carbon dioxide reacts with the calcium hydroxide and produces calcium carbonate and water. Calcium carbonate makes this solution cloudy, and since this has happened a little while ago, it's actually settled as a solid on the bottom and a bit on the top here. Now, this vessel did lose mass, and that's the goal of the prac. It's to show that mass does change in this reaction as carbon dioxide produced. The amount of mass that this flask lost should be equal to the amount of carbon dioxide that we made. And this flask I weighed as well to try and see if I could collect all the carbon dioxide and see this one gain in mass. However, I had issues with my prac. This didn't quite work. Part of it could be that I didn't seal around the top of my glass tubing here, so gas could have escaped. Secondly, possibly gas could have escaped through this join, or even as it came into the flask, maybe that moved up a bit, or not all of the carbon dioxide reacted in here. So there's lots of different reasons. It is a flawed prac. In fact, this actually lost mass, and most likely because when I weighed it, I had to take out the tubing and the cotton wool, which took some of the solution and some of the solid with it. Most likely why I lost so much mass, about 1.5 grams. Whereas this one lost about 4 grams, as it was supposed to lose mass. This one wasn't. And so I should have ethanol in here. Now our tests for ethanol, the first one is, obviously you can smell it. So if you get your flask and you waft and sniff, don't stick your nose over the top. That's a great way of knocking out your senses. Not wafted across, you can definitely smell the alcohol that has formed in there. Another thing we can test is similar to what we did with the alkanes and the alkenes, is we can actually use acidified potassium permanganate. You need to make this solution up fresh because otherwise it kind of breaks down on its own. Now, alright, what I have here next is just a pipette, and I'm going to pipette the solution into a few test tubes. I'm going to do a few tests. Only the first one is one that you actually need to know for this topic, but the other ones are just for interest. Okay, so the solution is cloudy, there is still the yeast in here. I could distill it, and that will get the clear alcohol solution in there and would probably increase the percentage of alcohol. But I'm not going to do that today. Instead, I'm just going to show you some of the simple tests. So the acidified potassium permanganate, when you put it into a solution of alcohol, just like with the alkenes, the alcohol will react with it and decolorize it. So it's this nice purple color. But if I give it a little bit of a shake and keep that up to help the reaction happen, hopefully I didn't put too much in there. Excellent. You'll start to see the colour lessening. I'll bring this up close because the other thing you can notice, and this will help explain what's happening there, is, there you go, beautiful colour change, is it's actually getting little black pieces in there. The reason for that is the little black pieces in there are manganese dioxide, which is formed as it is reduced due to the oxidation of the alcohol. That's the overall reaction that's happening here. this is the test tube up close where I've just done that reaction of potassium permanganate with the ethanol, and you can see the black powder forming at the bottom, and that is the manganese oxide. Commercially it says manganese dioxide, which is why I said that before. This is one I haven't reacted. You can see on the bottom, no powder. Alright, another thing is, in this reaction we should actually see, don't have one to compare at the beginning, we should actually be able to see the pH of the solution, which is red because of the carbon dioxide, that not all of it would have bubbled out of the solution, so the solution would be slightly acidic. To begin with, it actually would have been neutral because, there we go, it should have been neutral because water is neutral and sugar dissolved in water is also neutral, but I don't actually have anything to compare with, so the need of a control would make that a much better statement. Okay, the next thing we'll see is have a look at the fact that there's still sugar in the other solution. To test this, I've got a beaker of hot water and I have Benedict solution. Benedict solution is a way of testing for reducing sugars. Okay, so if there's still sugar left, which there should be, this blue after a couple of minutes should turn a nice orange colour. Just needs to sit in the hot water for a while to work. So again, showing that potassium permanganate one, and I'll give you an example of the reaction and how it works, is put the permanganate in. It's nice and purple. If I bring it up close and I give it a shake, see the reaction occurring. It's going to go quite quickly, I think. And you can see that black turning up on the bottom. You're seeing this solution is lightening and lightening. If it stays brown, that's also going to be some of the precipitating manganese dioxide. Okay, but it's totally lost its colour now. The pink colour that was there showing that that has been reduced. And we'll leave it a little while and we might see that powder settling down, but that's just the same reaction again. In this reaction of fermentation is my test. I was testing, maybe it's not hot enough, it should be enough, to see if there's any glucose left, and by all apparent reasons there doesn't seem to be any. The solution's still blue after a fair amount of time in there. That's the Benedict solution in there, and some of our leftover, our alcohol test. So it's possible there isn't actually any sugars still left in there. It's all been used up. Maybe I measured things out fantastically, or it's just too small to measure, or even that my reagent's a bit too old, not working very well. But it would be a bright orange if there were glucose in there that could be tested.